Harvard consultant who's down in Houston. I think he retired this time. I think our dialogue has gone over 5 years of retired. Anyway, here's mine.
So this is what you do in retirement. What I'd like to talk a little bit about is non-conventional oil and gas development activities, specifically is how they might be conducted in a cold weather environment, an Arctic environment. But as you'll see, obviously the BRIC countries, there's one that is pretty much in an Arctic environment, the other 4 maybe not so much. So I think there have been shale gas resources identified or hypothesized at least in all of the BRIC countries to some degree or another. But at the end of the day, you don't know what's there until you drill it and find out. What I'd like to try and do today is help folks understand a little bit of the terminology that we use in this area, because there is a lot of confusion. A lot of you, I'm sure, live here in the Washington area, and hardly a day goes by when there's not some kind of article in some newspaper that you have ready access to talking about hydraulic fracturing. So we'll spend just a few minutes talking about what hydraulic fracturing is. Then get into, at least for me, what's the fun stuff, operational issues and background, and what challenges are. And challenges for this meeting, I think, should equate to exactly what we used to get when I was working for ExxonMobil. Your boss would come in and say, I've got an opportunity for you. That's what he meant, really. It's a challenge. So what I'd like to talk a little bit about, what is non-conventional gas, what are the differences between conventional and non-conventional oil and gas development, and then we'll focus on some of the shale resources. I intentionally haven't chosen to address, or don't feel like we really need to address things like tar sand or oil sand development in a cold weather environment. That's being done today, and so whatever challenges there are being met and are pretty well documented there. Again, I can't point to this thing, but the yellow box there, permeability of concrete sidewalk out here in front of the building is actually better than what we produce from tight gas formations. So, just to give you a sense of what's there, shale gas, the context that I've worked in with Mike, we used to talk a lot about carbon capture and storage, and we've heard a little bit about that today. Shale used to be the cap rock that we put on all these storage reservoirs and it was going to contain CO2 forever. So, that's the kind of permeabilities that we're looking at. These rocks will not flow on their own. You can drill them and open them up with the atmosphere, and you may get a little puff of gas out of them, but that's about it. So, they require some type of active stimulation. So now talking about what's the same and what's different. We've been drilling oil and gas in the Arctic environment for decades, since probably the late 40s or early 50s, and probably even before that in some form or fashion. The drilling part of this and the production part of this activity are pretty much the same, whether you're talking about oil or conventional oil and gas resources or non-conventional. The drilling process, drilling the hole in the ground is fundamentally the same. The challenges we face with that in an Arctic or cold weather environment are the same as that you would encounter with a shale gas reservoir. One of the distinct differences, and I failed to mention, I have the point on the other slide, one of the distinct differences with a lot of these shale resources is the breadth of area that they cover. And that's a distinct difference between conventional oil and gas resources and non-conventional. A conventional oil and gas field may be a couple miles wide and a couple miles long, that kind of thing. Shale gas resources can extend for tens, if not hundreds of miles in any given direction. In some areas, if you look in the U.S., the Marcellus Shale, going from southern New York down through Virginia, West Virginia, probably down into Tennessee or something like that. So very, very large-scale resource potential areas for development. We do directional drilling in non-conventional resource wells. We also do it in conventional. We do virtually all offshore wells that we drill from a platform are directional wells. The distinction with most shale resource wells, though, is that we drill extended lateral or horizontal sections of those wells. The production profile is also different. What I mean is when you start producing a shale gas well, is fundamentally different than what you get with a conventional oil and gas well. With a conventional well, you get high productivity of oil and gas with very little water right at the outset, And as time goes on, water production generally increases. You see something of an inverse type active situation with shale. You produce a lot of water initially, and then that tapers off to what I would call some sort of residual level. But you get a big flush of water initially, and that's one of the challenges I think we're going to face if we start talking about production in a Arctic environment. So, like I said, these formations don't produce without some type of stimulation. And the tool of choice has been hydraulic fracturing. And what has made shale gas development work economically here was kind of the bringing together of two, I'll say, existing technologies. They're a little bit different in this application, but the existing technology of drilling a horizontal well, which we've been doing since the early 70s. And hydraulic fracturing, and in this case, multi-stage hydraulic fracturing, where you drill a long extended lateral, sometimes on the order of 2 to 3 miles long, come back and do multiple stages of hydraulic fracturing to bring the well into production, to produce economic volumes of oil and gas. So the terminology that I want to impart to you is essentially what I've suggested or hinted at already. When we get in, this is, at least in the U.S., this has clearly been a very controversial issue, the whole shale gas development scenario, if you will. The term hydraulic fracturing has come to kind of define the broad activity, when in reality it's a very short, discrete piece of this activity. We go through, in general, you go through an exploratory process. May take several years, 3 to 5 years is what I had on the chart. You may go through some well planning processes. You've identified a field through your exploratory process. You go through some planning, development planning, figure out how you're going to drill the wells and what sequence and what pattern and that sort of thing. That may take you a couple of years to map out, usually not that long. And then you're actually ready to drill the well. Drilling the well is relatively quick. It says 2 to 3 months here, and that's probably high side. In the Barnett Shale, when industry started working there, the wells were taking about 3 months to drill. In the Barnett Shale, which is in Dallas-Fort Worth area, in the Barnett Shale today, they drill the wells in between 14 and 21 days. A huge, huge improvement in efficiency, and that has significantly helped the economics. So you've drilled your well, you're ready to start doing something with this well you've got. And in the case of the shale, you need a hydraulically fracture. Like I say, the hydraulic fracturing process is a multi-stage process. And it actually only takes 3 to 5 days to do the full suite of stages that you're going to do. It takes about 4 to 6, 8 hours per stage to fracture an interval of productive formation. So the controversy, or the area of controversy, is this 3 to 5 day time span, a relatively blink in the eye in the life of the well, because when you're finished, hopefully this well is going to produce for anywhere from 5 to 10 to maybe 30 to 40 years, we think, in some of these cases. So they have the chance or opportunity of being very long-lived production properties. Which is what's attractive to a lot of oil and gas operators. To have these nice, long-lived resources. Just to give this a little context, and that doesn't show up with a darn, that's a sort of a top-down view with the center being the North Pole. I'll say the geographic North Pole, not the magnetic North Pole. Looking at the potential oil and gas resources. This, and let me clarify, this is conventional oil and gas resources, not non-conventional. So I couldn't find any publicly available assessments of non-conventional resources, but I would say you can take this as an indicator of the possibility that because these conventional resources are sourced from the same rocks that we're trying to develop as non-conventional resources. It's kind of if A plus B, A plus B will equal C here. So, this is a map, and strangely they overlay well for gas and oil. You can flip back and forth. The darker the color, the higher the resource potential. So the short answer there is that in the Arctic environment, there's huge potential resource, both conventional and non-conventional. The challenges, some interesting challenges here, just from a legal or jurisdictional perspective. A lot of these resources are underwater. The Unconventional law of the seas already establishes a process for establishing international boundaries, and in particular in the Arctic, international boundaries that go beyond the 200-mile range that's is part of the law of the sea from a jurisdictional standpoint. There's a process you go through that people are actually executing now to try and gain additional access to resources. But it's say something of a controversial process. The other piece of that, at least from the U.S. perspective, is that the U.S. is not a signatory to the Unconventional law of the sea. That's just beside it. Russia is, and I think that's significant as well. Like I said, the industry is well versed in normal drilling operations, conducting normal drilling operations in an onshore environment, in an Arctic environment. Production operations for non-conventional resources, though, are going to be a little bit different. There's a good document put out by the OGP on environmental practices for working in the environment or Arctic environment. Other issues, though, that are going to affect you, and issues that are addressed in that document as well, are really associated, obviously, with the cold climate conditions and the logistics associated with developing unconventional resources. The seasonality issues, the fast pace of development that occurs. Once you've identified a non-conventional shale resource, if you look at the example that's been set here in the U.S., where I would say it's clearly the most mature province in that sense, drilling non-conventional or shale gas wells or shale oil wells is essentially an assembly line process. And to do that, you have to have a lot of planning, a lot of positioning resources, and a lot of infrastructure either needs to be built or will be built to support that. So that gets you back to the area of extent issue. And that's one of the areas that I would say causes a lot of concern from an environmental aspect or side, because the aerial extent of these activities can be quite large. Activities, in these areas, there's a lot of equipment that's associated with it. In that 3 to 5 day period, the well site gets very, very busy looking. This is a well pad in the Barnett Shale, and they're actually conducting in 2 separate fracking operations. There's in the middle there. I don't know if you can see it very well, and since this pointer doesn't work at all. There's a row of 6 wells, but they're actually fracturing 2 wells at a time here, just for the sake of expediting their work. But one side is one well, and one side is supporting the other well. You can see there's a lot of infrastructure there. Pumps, sand or proppant containers. You need access to large volumes of water, which in a cold weather climate is going to be problematic. Generally we like to drill wells in an Arctic environment in the winter. Chris alluded to the stuff drilling on ice pads and things like that. We can do it in the summer, but it's sure a whole lot easier from a drilling standpoint to do it in the winter. Funny problem with water in the winter time, it freezes. So that's going to be a challenge. And then also when you get back to production, you're going to have issues when you get that water produced back. Again, you don't want that stuff turning into giant ice cubes on the surface. So there's issues with that. You're going to have issues with handling wastewater. There's handling, storage, and disposal issues associated with that. In the U.S., we're getting increasingly adept at recycling and reusing that water. There's going to be a lot of production infrastructure that's required. Flow lines, gathering systems, and then access to markets. I think, like I said, the challenges associated with oil sands are pretty well known, and I would refer you to people that are doing that for that information. I think it's a pretty well developed technology, and certainly it's being done in Canada at a very commercial scale. The challenges associated with non-conventional resources are a little different, and at kind of a juxtaposition. You want to be doing the production operations when the weather's a little warmer, but you want to be doing other things when the weather's colder. The logistics and infrastructure are going to be very challenging, I think. The equipment and resources needed to do all of this are going to require a great deal of planning, especially in some of these remote environments. And then you get down to the environmental side, you're worried about handling wastewater treatment, disposal, issues, there are also going to be challenges. All of those can be addressed. It's just going to take a lot of thought and planning, I think. So, with that, I think that closes.